Good evening. My name is Phil Rogofsky. I'm the Executive Director of the Maryland STEM Festival. And tonight we have an event we call the Engineering Career Discussion Panel. And it basically discusses some of the different areas of engineering. Engineering is a very broad discipline, as many of you know, or you may not know. And it's the E in STEM. So we've um, invited a bunch of engineers from different fields to talk about what they do and to let you know why they like their job, why they got into their job, and hopefully will inspire some people to pursue some of the different areas of engineering. So I'd like to start the program by asking everybody to introduce themselves, tell us what your day job is and who you work for. And I'll just go around. I'll start with Phil.
Good evening, everyone. My name is Phil Garrett. I'm a cyber systems engineer for Lockheed Martin. Currently, I work with a team of programmers looking at developing systems for data analytics, trying to look for malicious code or just hidden information in large data sets.
Great. Thank you, Phil. Jasmine, can you please introduce yourself? Tell us about your day job and who you work for.
Sure. Good evening, everyone. My name is Jasmine Alighty. I am currently an electrical engineer at Northrop Grumman, specifically in the space systems sector. So I work on my official title is a harness engineer. For those of you who aren't very familiar, harness is essentially all of the wiring and cables that go into a system. So I work with all of the wiring and cables of satellites, primarily national security satellites.
Thank you, Jasmine. I'm guessing that you haven't, since you work with national security satellites, you haven't been involved with the James Webb Space Telescope, have you?
No, I have not, unfortunately, but very, very cool project, and I highly recommend that everyone looks into that because it's been a long time in the making, and we're getting ready to launch soon. So, very, very impressive technologies that the team has worked on.
I know originally it was scheduled to be launched during the festival. We're a little disappointed pushed off, but we will definitely try to do some programs about the launch of the web when it happens. I believe it's scheduled for December. Bertina, please introduce yourself and tell us a little bit about your day job and who you work for.
Hello, my name is Bertina Hanley, and I currently work as an aerospace engineer for Peraton Corporation. I'm on a program called Artemis 2, which I'm trying to send the first person to Mars. And it's fun.
Thank you. Maya, can you please introduce yourself? Tell us about your day job and who you work for.
Sure. Hi, I'm Maya Tattenklo. I'm an environmental engineer. I work for a consulting firm called RK&K that's based out of Baltimore City. I mostly do wastewater treatment plant design. So we work for cities, states, counties, things like that, and we design all parts of a wastewater treatment plant system.
Great, thank you. Diana, can you please introduce yourself and tell us a bit about your current position?
Sure. My name is Diana Hugh. I work for Jensen Hughes and I'm a fire protection engineer. So I usually explain that as being the people who design things like fire suppression and fire alarm systems, but I do a lot more of the code side of things. So looking at building and fire code regulations. And a lot of my focus is on healthcare and government projects being in the DC area.
Great, thank you. I'd like each of you to talk a little bit more about what you do during the day, what your major tasks are, what a typical day in the office is like for you. Phil, could you please start?
A typical day for us, it all depends on who our client base is. I work in national security. So we have mostly military based clients working outside of secure facilities that have open networks where they stream very large data sets. It's really hard to interpret the data as it comes through so quickly. So my programming staff tries to develop analytic methodologies to go back and look at the storage locations and look for hidden viruses, hidden malware, and just think about all these locks when people are getting hacked and they're getting locked out of their computer because their computers are being encrypted. We look for things like that before they attack. Because a lot of times they don't send the code in all at once. They'll send the code in bits and bytes, and eventually the code will put itself together. Well, in very large data sets, it's extremely hard to find. It's like looking for a specific grain of sand on a beach. So we have to use machine learning and work with data scientists to really figure out what we're going to find. Just, use a lot of math to figure out where are the bad actors in all the data. So a lot of times
what are some of the key tools you use during the day?
A lot of times, I want to say that obviously we use computers. And I thought about that question, but I really want to stress that we use tools that others have made, meaning that engineering is not just designing equipment. Now, we've done that, or designing new software. A lot of times we're using off-the-shelf software packages or commercially available software packages and using them in innovative ways. That's probably one of the most important concepts. Is don't get stuck on, hey, I can't invent something because I can't think about it. No, it's just using pre-made software out there and just using your imagination, your knowledge of math and technology to put it all together in a different way. And that's probably the most important thing that we do every day.
Okay. Thank you, Phil. Jasmine, please tell us about what you do during a typical day, your major tasks, and also some of the key tools you use.
Sure. So as a harness engineer, I have primarily two areas that I'm concerned with. One side is the design of the electrical components in the satellites, and the other side is the manufacturing of all of the cables that go into those satellites. So pretty much on a daily basis, I'll spend about half of my day on the design side. By design, I mean 3D modeling, creating electrical schematics, actually putting on paper, or I suppose on the screen, exactly which cable is going to connect to which component, creating wireless, creating bills of material, basically just all of the documentation and the design that's going to apply to the build itself. And then for the other half of my day, I'll spend on the manufacturing floor, kind of checking in with the actual people who are building the cabling systems, and just ensuring that everything is running smoothly, that we don't have any shortages of wire, that we don't have any damage to the wire, or if we do, how are we going to address that problem? So it's really just kind of interacting with the people who are actually building the design, and making sure that there's kind of a smooth understanding and smooth communication between us as engineers who design and the manufacturing team that actually kind of brings that design to life. As for the tools that I use, just a couple of kind of specific examples. I know that high schools are starting to teach more of the 3D modeling now. So if there are any high schoolers on this call, you might have taken some sort of, SolidWorks or AutoCAD or Inventor, something like that. We use at Northrop Grumman primarily Creo to do a lot of our design work, both 3D modeling as well as electrical schematics. We also use Excel a lot, and I think probably a lot of people on this call would say that they also use Excel. It seems on the surface kind of a basic technology, and even as someone who's not in engineering, you probably use Excel in the vast majority of professions just because it's so functional. But as an engineer, I've really learned how valuable the tool is, and there are all these macros and code and kind of very specific functions that Excel has built into it that we can use not only in communication, but also in calculations and in writing programs. And I personally have used that a lot in my career thus far.
That's very interesting. I'm sure people don't think of Excel as something used by engineers, that it's more of a basic tool for your everyday use and for accountants. So thank you. Bertina, please tell us about your day-to-day activities, functions, duties, and some of the key tools you use.
Okay, so currently I'm on the systems engineer side of the house. We have a software team that is in White Sands, and we're in the beginning stages of the program. So in order to send a person to Mars, we have to have a vehicle, and that's what we're working on, is to be able to have this capsule where people are able to be contained and make it safely. And so right now we're doing a lot of documentation with the systems. We're using some of the legacy from the Artemis 1, as well as the people that are in White Sands are doing the software. And the hardware, I'm sorry, is kind of like another company's picking that part up. Are the tools that we're using now are mostly commercial COTS product, commercial off-the-shelf products. We're using a lot of Excel, and since we're doing documentation, that's being done in Word, and just seeking a lot of government approval, and doing a lot of scheduling to make sure that we try to stay on task with the program.
I'm guessing you're looking at a lot of the past manned missions, different types of systems to help you plan the Artemis craft.
Yes, absolutely.
Which ones in particular, besides Artemis, are you looking at?
Well, we're just looking at Artemis 1, so that legacy system.
Okay, great. Thank you. Maya, please tell us a little bit about your typical day, your day-to-day activities, and some key tools you use.
Yeah, so my typical day kind of varies depending on what type of project I'm working on. So we do design projects from like inception. So we'll do a study, we'll go out to a wastewater treatment plant, do a site visit, kind of see what's there, see what the conditions are, see if they have a problem we need to solve specifically, or what needs to be improved. We'll do a lot of data analysis, so see how their existing plant is running and see what the influent wastewater looks like, right? And then we do that for a variety of plants. So it can be a tiny plant in like, Garrett County, Maryland, way Western Maryland, or it can be a large plant like here in the city of Baltimore, which serves like the whole city. And so then depending on those projects, we can do like a study and recommendations for what sorts of technologies they should look at. And then otherwise we'll do plans, drawings. We use AutoCAD, that was already been mentioned. We're doing more and more drawings in 3D and creating 3D models, especially of building systems, to kind of be able to see like where like pumps and pipes and HVAC equipment and lights, all those things are going to go, and so that they don't interfere with each other. So a lot of those computer softwares we use. We also use, a hard hat and a tape measure when we go out to the field to see what's there and kind of field verify. Make sure that everything on our drawings is accurate and correct. And then we see through construction. So once something that we've designed on paper, what we produce is something that looks like what you'd imagine a blueprint for a house. We'll do that for, a whole wastewater treatment plant or one process. And then when it's being constructed, we need to be on site from time to time to kind of check in with the contractor and make sure everything's going well. And if there's anything that we missed or need to resolve on site, then we need to, solve those problems in the field.
Plants you work on, are they mostly in Maryland?
Yeah, I've mostly worked in the state of Maryland. I've worked at a few plants in Virginia and Pennsylvania as well. I think one in West Virginia. So we also work in Delaware, and we're branching out to North Carolina as well.
Great, thank you. Diana, please tell us a bit about your typical day or some of your activities and functions and some of the key tools you use.
Sure. I used to always say, I think, there's no such thing as a typical day, which is probably common for a lot of engineers. I mentioned the healthcare aspect for doing a life safety survey at a hospital. The hospital can't come to you, so there tends to be travel involved, which has been a nice aspect to get to go to different states and work with different people. So doing actual surveys in buildings, and I mean that's I think kind of like Maya was saying, like you've got a hard hat, a ladder, flashlight. You're getting up there and taking a look at things, and then there are other times we're just looking at other types of existing buildings, and like I said, being in the DC area, it can be neat to be behind the scenes in some of the government buildings. And then back in the office, as I mentioned, I do a lot of code work. So in addition to Excel, things like even just Word, I always say there's a lot of still English and writing involved because even though you do something technical, you're generally communicating it with someone who may not have that same technical background. So, and just documenting what you do along the way. There are other folks that I work with, as was mentioned, CAD's popular. Revit is also one of the 3D models we're starting to see when designing buildings so that you're detecting any clashes when you're laying out ductwork and piping and such. Um, and then we do have specific to fire protection. There are things like FDS modeling for actually modeling a fire in a building, and things such as Exodus that are egress models. So can we get people out of a building in time? And you can use those in conjunction to see what's the rate of fire growth versus how fast can you get people out of the building. So
Great, thank you. But adding on to the comments about Word and also Excel, both those tools have a phenomenal amount of capabilities that most people really don't use and don't touch on. I'm example of that. I mean, there's so much that both Word and Excel can do that doesn't get used by most people. It's quite a tool in itself. I'd like to ask each of you what you like most about your job, what excites you, what gets you motivated to get to your desk in the morning. I'll start with Bertina.
So I'd say that my every day is different. um, so that's what I like. I don't like something being the same routine. I like to be able to learn something. So with the new program, I may have to research something or look at other documentation or something. So I like that aspect of my work.
And what do you least like about your job? What do you dread or not want to tackle?
Hmm. I really don't have anything. I guess I used to could say
Okay.
traffic, but now that I just roll out of the bed.
Well, that's a positive thing that there's nothing about your job that you don't like. So
Right.
that's great to hear. Okay,
Yes.
Jasmine, can you please tell us what motivates you, what you enjoy most about your job, and what you like least or don't enjoy?
Sure. I would say that the aspect of my job that I enjoy the most is kind of getting to see and be part of technology that a lot of people never get exposed to. So, as a satellite engineer at Northrop Grumman, we are kind of on the leading edge of space technology, and in a lot of cases, we as well as other space contractors are creating systems that have never been built before and that are the first of their kind. So I think as an engineer, it always amazes me kind of the capabilities that we have these days. Because if you had asked someone 10 or 20 years ago, or if you had told someone that we were going to be building some of the things that we're building, they would have said, "What? How? How are we going to do that? That's crazy." But we can do that now, and it's very, very cool to get to be on the floor with the technicians, right there, seeing these things come to life for the first time or for one of the very first times. So I would say that that's my favorite. My least favorite part is hard to say. I think probably just being able to balance my work life with my personal life is probably the biggest struggle that I have. Just because a lot of times, uh, and Bertina mentioned this, your day doesn't look the same. So you kind of, it's hard to schedule. It's hard to schedule things when you have such a different schedule every day. So sometimes, I'll start work at 6 a.m. Some days it'll start at 10 a.m. Sometimes it'll end at 5 p.m. Sometimes it goes until 10 p.m. So it's a little bit difficult to try and schedule time to be with friends and family or to go to the gym or to cook meals when a lot of times my work responsibilities will kind of be so varying. But I mean that's both a good and a bad thing because like Bertina said, I very much enjoy kind of having that spontaneous schedule and never knowing exactly what to expect, because if you have the exact same thing going on every day, then what kind of a job is that? It's boring. So I suppose that I turned the negative into a positive. But yeah, I very much enjoy a lot of aspects of my job. So it's,
Well, that's great.
yeah.
Thank you, Jasmine. Diana, please tell us what you enjoy most about your job, what motivates you to get to your desk, and what you could live without.
I think the big thing, like the underlying concept when it comes to fire protection engineering of keeping people safe from the hazard of fires, motivates me because even when you're, might be doing something that seems minor or kind of tangential, it's still bringing together the goal of creating an environment that keeps people safe. And so feel like I always want to keep that in the back of my mind, even if it's something tedious that I'm doing or, um, you know, otherwise like that. And I think I feel like a lot of people, there are so many things that I do like about my job. I will say the aspects, kind of not so much I guess project management, but like financials, like, you're not just an engineer, at least at my company, is that there are other things you have to do. So things that I might not have as strong of a background in when it comes to projects have been more of a challenge for me along the way as I've learned. But yeah, I mean, it's interesting because it's, you aren't just going to be sitting at your desk like solely doing technical work over the course of your career, most likely. So
Okay.
it's been
Great,
an
thank you.
area of growth.
Okay. Maya, please tell us what you enjoy about your job, what motivates you to get to your desk, and what you could live without, what you don't enjoy dealing with.
Well, I really love wastewater treatment. Kind of like what Diana said, I think it's a really important public health service that nobody thinks about when they flush the toilet or take a shower or anything like that. But it's super important, it protects our health and it protects like the Chesapeake Bay in this area and stuff like that. So I think that's really cool. I think that everything we do is really interesting. We deal with chemistry and biological systems and then actual like mechanical systems all together. We sort of have to integrate them to make them achieve like a clean product at the end, which is your clean water. I love that I'm learning something new every day, whether it's from other disciplines like HVAC or electrical engineers or the structural engineers, things like that. But also just there's new technologies coming out all the time, new types of equipment, new ways to treat wastewater, which is super interesting. So I can't say that there's a day goes by that I don't learn something new. And so like that's really like my main driver. It just stays so interesting all the time. For things that I don't like, I would say that in addition to like the sort of bureaucratic or like administrative part of things, something that I have struggled with, and you wouldn't be able to tell it by this panel, but it's at least in civil engineering, it's a very male dominated industry, and that can be a little bit tiring in a way. I've never experienced really like direct, like, I don't know, bad outcomes from it, but it is just like kind of tiring to be like the only woman in the room, the only person kind of speaking up, and then kind of always feeling like you have to prove yourself or just be like a little bit extra smart or something like that. And I think that's something that's getting better in the engineering field, but we still have a ways to go.
Okay. Yes, unfortunately, that is true. So, but thank you very much, Maya. Phil, please tell us what excites you about your job, what motivates you to get to your desk, and what aspect or aspects you could do without. You'd like to make go away with a magic wand.
Those of us who have to deal with staff.
Mhm.
No, sometimes dealing with people and individual problems can be probably the hardest part. Fiduciary
Mhm.
responsibility and dealing with budgets, that can be kind of tiresome as well. But honestly, getting up and learning new stuff every day, and I know that that seems to be used over and over and over again. It's sort of a catchphrase, but it's true. I've only been in this position for about 3 weeks. So prior to this, I worked in chemical weapon demilitarization for 22 years. So as an electronics engineer, um, it was difficult for me to learn chemistry, gas chromatographs, mass spectroscopy, liquid samples, air gaseous samples, but that was the fun part. So I can develop my little circuit, but how does it fit in the whole scheme of things? That was fun. That was enjoyable, and I really did like that. But sometimes dealing with people, checking their time cards, the office politics, that can sometimes get old. So get me out of my cubicle so I'm not playing whack-a-mole, and get me out into the plant with my steel-toed shoes, my safety glasses, and my hard hat. I'm happy.
That's great. The next question I'll start with you, Phil, is do you remember what first interested you about science and STEM and why you chose the area that you are currently in? And I'll start with
Yes,
you, Phil.
yeah, STEM didn't exist when in the
Well,
early
that's why I
80s
say
when I was in high
science or
school.
STEM or technology, any one of those areas, I understand.
That's a really simple. My mother and father worked in manufacturing. That's
Mhm,
big here in Baltimore.
mhm,
They all worked on the assembly line. Uh, Ma Bell years ago, if you
mhm,
remember, all the phone lines were all owned by Ma Bell.
mhm,
Western Electric asked their employees to bring their children to talk to the engineers
mhm,
and to see what they wanted. This is when computers were first new in the late 70s, early 80s, and they had this 101 electronics kits from Radio Shack, and they taught us how to turn light bulbs on, how to make buzzards, just by using springs, wires, and batteries. And I must have been, I'm sure, in middle school or junior high, and that was it. Then it was the problem is how do you get there to get to where you want to be? Coming from a low income community, uh, the service was my avenue into college,
mm,
and then it just started from there, and it never ends. And I did want to point one thing out. We talk about office products, but
mhm,
remember that you don't need to purchase Office. You can use Libra or
mhm,
OpenOffice as free downloads so that you can have Excel, Word, and other percent. So the kids can practice with it now to do their homework and their school papers without having to ask for the initial investment of trying to
mhm,
purchase Office 365. So there
mhm,
are avenues out there without having to buy software, especially something as
mhm,
expensive as
mhm.
Microsoft Office.
Now, you're working in the area of cybersecurity. How did you get into that specific area? What attracted you about cybersecurity?
Um, it had to. I was a controls engineer before this at a coal fire power plant, and I had to move back to Maryland for family reasons. So I looked at where that my master's degree could best be used.
Mhm,
So national infrastructure, the NSA seemed to be a really good place to start,
mhm,
and they really it was something taking it from controls engineering and how to secure our national infrastructure, which is now a federal mandate, now going over to national security and intelligence and looking at some of the large amounts of data. I thought being in a control room with 5 or 6 power plants or 5 or 6 boilers was large. Not it's
mhm,
nothing compared to some of the data we see nowadays. Even
mhm.
Google, Yahoo, Amazon, all of them are very large data sets. How do you get information out of that going by so quickly? That's exciting, and I think that's what really caught my attention.
Okay, thank you. Jasmine, so what first interested you or attracted you about STEM, science, engineering, and what attracted you about your specific area that you're in now?
Yeah, so I think what first really attracted me to STEM in general is just it bothered me that I didn't know how certain things worked. So I remember getting my first cell phone and I didn't understand how we could be speaking to someone on the other side of the world with no wiring, and it didn't make sense to me. And that could be said for several things, watching a TV or a
Mhm,
camera, just that kind of curiosity for wanting to know how somebody was able to make that and how it actually works. So just kind of that generic curiosity got me and led me to engineering because engineers are typically the ones who design those types of systems. Regarding getting into space and satellites, um, I'm not sure if there was a specific event that triggered that. When I was in college, I was approached by someone who worked for Northrop Grumman, and we got into talking about what they do for their job. and how they get to make all this stuff that goes up in space. And I was very, very impressed with what they were doing, and um, kind of what the company was doing as a whole. And I said, you should give me some more information on this. I would love to learn more. And I ended up getting recruited by that same person to go and do exactly what he was doing. So for me, it was really just word of mouth. And again, just the curiosity to better understand something that a lot of people don't understand.
Thank you. Bertina, what first attracted you to science and engineering, and what attracted you to the specific area you're working in now?
Okay, well, growing up, I always loved math. And so I'm incorporating that in college. My first major, I felt wasn't hard enough. I was kind of bored. Actually, the professor would send someone to knock on my dorm door. So I decided at that time to go to the library and let me read and see what it is that I want to major in. So I decided to major in physics. That would be incorporating the math along with, hey, this is something that's hard or harder. So I majored in physics and then electrical engineering. And so that's how I started. And my brother also was an electrical engineering major. So when he would come home, he would, hey, let's put together this transistor radio. And I would see him working math, and he'd say, well, since you like math, how do you like doing math that's, could be a couple of pages long? So it was always there for me, and it was easy and something that I loved. And so initially, I was working over at the agency. So I was in defense for about 20 years and decided that I wanted to travel when and where I wanted to. And so that's how I ended up on first at NOAA and then on a NASA program recently. So my love
Great.
for math is what started.
Okay. Maya, what first attracted you to STEM and science, and what specifically attracted you to the area you're working in now?
Well, I, growing up, always had that curiosity of how things worked more about natural systems. So, just like streams and lakes and rivers and being outside in the forest. I grew up in New Hampshire, so I spent a lot of time outside hiking and that kind of thing. So, I was always very fascinated by nature and those systems. And so, actually, in undergrad, I studied natural resource management, like environmental science. And it was less math focused than most engineering programs. And what actually led me to environmental engineering and wastewater treatment specifically was I spent 2 years in West Africa in the Peace Corps. And I saw kind of like firsthand how important that sanitation piece is in people's daily lives, something that I'd always taken for granted, that I had clean drinking water and a wastewater system. So then when I came back, I went to grad school for environmental engineering, because to me, it like is a nice blend of kind of what we do is we use natural systems and then we like amplify them, right? We design the perfect conditions to make them kind of work in overdrive. So in like a smaller footprint than say like a natural stream, that's what we're creating in a wastewater treatment plant. And so that's like kind of what led me there, was the like natural and then public health part together.
Thank you. Diana, what attracted you to STEM and science, and then particularly the field you're in?
I guess kind of like Bertina, I was a fan of math growing up. And so with enjoying math and science, I actually went to Eleanor Roosevelt High School for the science and tech program there. And when I got out, I figured, engineering sounds like the thing for me. And so I ended up at the University of Maryland as an undecided engineering major, and it was kind of process of elimination there, where like I was never a fan of chemistry, the electrical stuff didn't really interest me. And I think I narrowed it down to mechanical and fire protection. And then I went and talked to the professors at the department, and they said it was a small, close-knit department. They had 100% job placement rate, and there was a class where you got to burn things. So I was like, this sounds like fun. And I actually got to go talk to one of the professors who was doing experiments on fire and zero gravity. Back then, doing like parabolic flights, they were doing experiments in. And that sounded fascinating to me. And I think I also had a little bit of a CSI like mindset of, the forensic side of things sounds really neat. Um, so I think there were just a lot of aspects, and I think, it was a good fit for me.
Okay, great. Thank you. I'd like each of you to talk about a little bit about what you feel are some of the main skills needed to perform your job for someone who will be doing your type of work. I'll start with Jasmine.
Sure. Um, I think really the number one skill that you need to be an engineer in general is the desire to be an engineer, which sounds
Mhm.
very basic, but at the end of the day, you can do all the calculus and physics and dynamics, you know, stuff that they teach in schools all you want, and you can be great at it, you can be not so great at it. But if you have a passion for what you're doing, you're a lot more likely to be very good at that job. So I think having a passion for being an engineer or being in a STEM related field in general, as well as an openness to learn, because I guarantee that every single day you will interact with someone who is going to have a different mindset from you, or who wants to do something a different way than you want to do it, or is going to challenge the way that you want to approach a problem. And if you're open to finding a different solution, or to going about a problem in a different way than maybe you wanted to, or if you're presented with a challenge that you simply don't know how to address and you have to figure out a way to learn a skill or to learn a concept, I think you'll be able to be successful at that career regardless of what specialty you're in, if you have the desire to learn.
Great, thank you. Phil, what would you say are some of the skills that are critical to someone in your role?
I would say definitely a questioning sort of mindset. Why does something happen? Uh, but I think more important is the you have to be innovative in the way you're thinking. I don't like to use that term out of the box thinking because I think it's overused. But again, most of what we do every day is building on the tools, techniques, and the research that was done before us. So going in and learning all that, and taking the time to understand what people did, why they did it, what the results of their testing, the results of their engineering, what they were, and how you can use that uh, to to solve your customers' problems. Don't try to reinvent the wheel every day. Use what's already out there. Save yourself time, save yourself energy. Just think about understanding what you've learned in school, what you learned continually throughout your life cycle, your work life, and how you're going to use that. It's not something simple. I mean, it's nice to say you should be good at math. Realistically, you can figure that out because people have access to the resources around them. But can somebody take, again, this commercial off the shelf hardware and software and configure it in a way to solve a customer's problems effectively and efficiently? I think that's pretty important.
Okay, thank you. Maya, what would you say are some of the key skills to someone in your position?
I would say, yeah, in addition to math, though I agree with everybody. I wasn't like a huge math person in high school. I did fine at math. I wasn't great at it. I didn't love it, but I liked it okay. But somebody said it earlier in producing reports. I think the thing that people always miss in engineering is writing. It's really important to be a good writer, to work on your writing, to be able to communicate your ideas, right? So if that's communicate in a meeting to your clients via PowerPoint or just a discussion, or to write like a clear and concise report that really like gets your message across, or even a proposal to win a job in the first place. I think that's a skill that is like never really talked about as much as it should be in the engineering field, because it is like a huge, like you can invent something, you can figure something out, but if you can't communicate it, it doesn't mean much. So I think that communication in general, specifically writing, is really important.
Okay, thank you. Diana?
I feel like I want to echo a lot of what's already been said. I always push the communication side, whether it's communicating with colleagues and, working in teams, because very rarely will you be independently working on something. You'll have someone reviewing what you do, or you'll be collaborating with people, or if you're communicating to your client, or you have to communicate to, the authority having jurisdiction who's going to see if they agree with your design or not. That's a very important skill. And the math, as much as I always bring that up and everyone brings that up with engineering, for the work I do, um, building and fire code regulations are really written to no higher than an algebra level. Now, I took much more beyond that in college, and if you go into, a research aspect of fire protection engineering, sure, you'll use that, but in my everyday life, that isn't um, what I'm doing. So, and I agree with Phil about, I hate to use the phrase too, but the think outside of the box. I mean, you have a client who's coming to you with a problem, and I, as much as I used to always say, I'm like, oh, you've got a building code, a fire code, it's black and white, like how you can do something or you can't. There's new products, new designs every day, something that the code hasn't caught up to yet, so you have to judge based on past research or finding out if you need new research done. How are you going to approach this problem and help come up with a solution?
Okay, thank you. For Tina, what would you say are the key skills for someone in your position?
Okay, I would say problem solver and being innovative. Problem solver, um, there's always something that arises almost on a daily basis where it may come down from management or some higher up where we have to decide how we're going to work through this issue. So being a problem solver as well as being innovative because engineering, you're usually doing something different. It's an evolving, whether you're electrical, civil, it's always something that's evolving. You can buy anything, an iPhone and or a laptop, and 20 seconds later, something new is coming out. So those I think are key. I mean, it's a lot of things, and also the love of whatever it is you're doing. There are people that major in engineering that decide after a few years that's not their thing, and I think that is because they didn't have the love for it. It was just something that they were able to do, get through college, and that was their major. And then, hey, I wanted to do something else. So um, that would be what I would say: being innovative and problem solver.
Okay. What would each of you say is the biggest challenge facing your area of engineering? What are the hardest things that they're dealing with and will be you foresee dealing with in the very near future? I'll start with Jasmine.
I think there are two challenges in my field of kind of space systems engineering as a whole. One of which being that a lot of times we are being asked to do something, and I mentioned this before, but we're being asked to do something by a customer that hasn't really been done before. So I know Bettina mentioned earlier getting someone to land on Mars. Whenever you have a first time type project like that, there's a lot of risk involved because you don't have any sort of prior evidence or prior knowledge of exactly how it's going to go. So Northrop Grumman is kind of one of those companies where a lot of times we work with other companies to create systems that haven't been created before. So we're working on something now, a lunar lander with a couple of other contractors, and we have not had a lot of people on the moon, as everyone knows. So trying to create an environment on the moon, on the lunar surface, where we really have a very limited amount of knowledge of how people can live there, what sort of resources we need, what sort of things can go wrong. It's very risky because we don't have the facts or enough facts to know exactly what's going to happen. So I think that that's one thing, is just kind of being the first to go about something. The second challenge that I see us facing is competition, because there are other companies and there are other countries for that matter that are always trying to build something better. So, for example, for building a satellite, we're always trying to make it smaller, more compact, fit more components in a smaller amount of surface area. We want to make it go faster. We want to make it communicate more effectively. We want it to have more functionality. So there's always kind of a next level that you can take your project to, and being able to keep up with the latest competition on that is always a challenge, because of course you always want to be able to build the best thing possible. So you kind of have to prioritize certain things and minimize other things in order to find that optimum balance.
Thank you. Maya, what would you say is the biggest challenge facing or that your industry will be facing?
I would say climate change and weather. We design based on nutrient and pollutant loadings, but we also design based on hydraulic loadings. And when you see these crazy wet weather events, 2018 was like the wettest summer on history, or the wettest year, I should say. It kind of blows the hydraulics and like the capacity of actual like volume of water going through a plant kind of out of the water. So that's something that we have to adapt to, is designing our systems for higher sort of peak flows. So what happens is, even though that water shouldn't be into the wastewater system, there's a lot of infiltration from rainwater. And so it does end up at a wastewater plant, and you have to be able to deal with it so it doesn't spill on the ground. It doesn't cause any sort of environmental issue. And so to me, that's like because that's changing. And again, like we don't know what's going to happen or how it's going to change or how it's going to impact us in the future. So we just have to have like higher safety factors and things like that.
Okay, thank you. Phil, what would you say are some of the biggest challenges or the biggest challenge you're dealing with and you foresee coming down the line?
I'd say getting the word out as to how many jobs are out there. It's interesting when I tell people in a roundabout way what I do. Their first thought was, I could not sit in an office all day long. And I kind of giggle at it and say, well, you got to get over that misconception that cybersecurity is all about sitting behind a keyboard. So currently, Lockheed Martin tells me there's 22,000 cybersecurity jobs in Maryland alone. So these jobs range from going out in the field and configuring hardware, running cables, setting up fiber, doing building communications for their HVAC, electrical systems, basic SCADA networks. It's getting that information out there. It's not all just programming. It's not all math. It's not all engineering. It's not all learning new Python or any other remote language. It's really, it encompasses all of that. So it's getting the word out there and saying, hey, what are your interests? Because I can bet that if I sat there long enough, I can find a role within the cybersecurity industry. And it has to do not just with national security. It just happens to be what I do now, but I did other activities in manufacturing, small plant processing, and even homes. So there are multiple avenues. It's getting that word out and trying to grab these young people's attention. Hey, come look at us. Come spend a summer with us. Let us help fund your 2-year education, your 4-year education. Let us introduce you into something you don't know about, because the problem is they don't know what they don't know. So it's really up to the 5 of us to reach out to the younger generation, just like Western Electric did for me. Hey, Phil, there is so much out there. Let me show you one little piece and you figure out which one you like. And it's just so happened that I've had a varied career up to now. And it just so happens that I'm in cybersecurity right now. And I'm behind a keyboard most of the time, but that doesn't mean that all of it's behind a keyboard. And don't get math anxiety. Don't get worried about standing in front of a crowd. People are shy. Communication is important, and working with teams are very, very important. But just know that there are places for everyone, and getting that word out is increasingly difficult. And that's why I'm helping Lockheed and our company try to get the word out to younger people.
Okay, great. Diana, what would you say are the biggest challenges or challenge facing your industry, your field of engineering?
Well, I think it's interesting, kind of going off of what Phil said. I mean, fire protection is a pretty small field, and so the same kind of thing of people don't know that we're there. So in terms of recruiting, and I think the same thing holds when I went to Maryland, that there's 100% job placement rate. And I think, again, similar to what Phil said, if you have an area of interest, you can fit somewhere in many engineering fields. Unlike me, do you like chemistry? Maybe you want to design a new fire suppression chemical. Do you like electrical? There's different fire detection, things of that sort. So I think we have a lot of similarities there. But in addition to, just recruiting more for the field in general. I think you mentioned the festival had a wildland fire uh, panel discussion, and I know that's one thing. It was covered less so when I was in school. We were very building focused, but I think wildland urban interface fires are a major issue, and it kind of ties to what Maya said about climate change, because obviously that can be a major driver for some of these fires. And then I think the other thing more on the building side is just new materials. Jasmine mentioned, you get to be on the forefront of coming up with new technologies. Well, when, new technologies are developed across all different fields and they find their way into these buildings, do I know, is this going to burn? How is it going to, will this material burn differently if it's placed in a building horizontally versus vertically? Is it covered with another layer of something to be insulated? Will these products, are they fire safe? Even appliances and things like that. So I think, as technology of all fields evolves, then we're kind of catching up to make sure that people are still safe from any of the fire risks involved.
Okay, great, thank you. And Bertina, what would you say is the biggest or a big challenge that is facing our industry?
I would say knowledge base. I consider myself an older worker. On the programs that I've been on recently, the workers are even older than me. They are really the knowledge base. I'm new to the space industry, but the people are very, very knowledge based. And I feel that with us working from home, that we're not getting the connection that we would otherwise have if we were in the office, just hearing things or incorporating other, um, I guess, work topics that, maybe you're just standing around and you're talking about a particular topic and you're like, oh, well, I didn't think about that, as opposed to us being at home and, doing our daily work, we're able to turn it in. But I think that the knowledge base is something that I'm concerned about, as well as I guess the stats, the educational stats as well, where the U.S. has fallen so far behind other countries. And I don't, whether it's English or math or whatever the subject may be, everything's important. And I hope that the U.S. decides in some kind of way that, yeah, we have this vast educational system. In some places, we are people are coming in that really don't have the knowledge to run programs, but want to be program managers. That we kind of tighten up on that a bit so that we can move from 35 out of 37 into a much better space. So that's my concern.
Okay, thank you. Well, this has been a great discussion. I think it's been very informative, and there's been a lot of good information discussed. And many of you has touched on this, but if you had one thing to tell a student why they should enter your profession, I'd like you to go around and ask just one thing, because we're running out of time. So what would be the number one thing you would tell a student why they should enter your field of engineering? And I'll start with Phil.
Employability.
Mhm.
Yeah, you want to have a job, you want to be have income on higher than average income. That's where you want to become an engineer, especially if
Okay.
you want to get into cybersecurity, because there are thousands of jobs out there at every level, not just the 4-year degree level. So people need to keep that in mind.
Okay, thank you. Jasmine?
Confidence. If you can get through an undergrad degree in engineering, you will be able to solve problems and you will be able to pretty much take on any challenge that you are given because everyone knows that the engineering curriculum is rigorous regardless of what specialty you're in, really STEM in general. And I think if you can make it through that, you are really setting yourself up for success in the real world.
Okay, great. Thank you. Bertina?
I agree with both Phil and Jasmine that both are very important. It's great to have a good salary where you can do more than I say, I go to work for 8 hours. It affords me to do what I want to do the other 16 hours of my day. So that, and yes, it does give you the confidence. So sometimes that's good and sometimes that's bad, but for me, it's good. That's it.
Okay, thank you. Thank you. Maya?
You'll never be bored because every day is different. You're always learning something new.
Great, thank you. And Diana?
Gosh, I feel like I again want to echo everyone else here. It's a great place to, use your curiosity and learn more every day as you go. And, if you're in fire protection, maybe you get to burn some things. So
Okay. Well, thank you very much. I appreciate everybody taking the time to be here tonight. I think this was a wonderful discussion, and I'm sure the people who watched it today and will watch in the future will gain quite a bit from it. I'd like to ask my panel to stay on after I wrap up the program, which I'll be doing right now. But thank you for watching this program. If you have any questions or comments, feel free to reach out to the Maryland STEM Festival. We can easily connect you with any of the speakers today and other speakers. So have a great evening, and thank you very much for joining us this evening.